The entire essence of a Leetcode daily problem is that it should be different, but I don't know why they are continuing with the same problem. Hi guys, good morning, welcome back to a new video. In this, first of all, I hope it's doing good. In this, we're going to see a problem, minimum increment to make array unique. Another similar problem as that of last 4 days. Cool. Let's see. It simply says that we are given an array nums, and in one move, I can pick any index element in the array and can increment that by 1. That is my one move. I will count it as a one move. I have to return the number of moves to make every value in the nums unique, which means every value should be different. And again, the prime thing is that you can only increase a specific value. Cool. So for example, in this case, I have 1. For sure, I cannot decrease it. So I can only go forward, which means I might end up increasing it. So a question for me, should I increase it or not increase? That's a question for me. Now it's obvious that he is the minimum value in the entire array. If I will increase it, there's a chances that it will end up colliding or maybe becoming same with the other value. So I realized it is always good that I should look at my smallest value, and then again I look at the smallest value and I will make it okay. Bro, you keep as it is, you be as it is. The value which is just higher than you, I will see is it same as the smaller value. If it is same, I might end up increasing it. If it is different, okay, no worries, move on. So you realize because you cannot decrease a value, you should not go and check the extreme minimum. He will remain as it is. You cannot decrease him. No, if you end up increasing him, he might end up becoming same as the other value. So leave it, leave him. Some people are there, you should leave them. Same as the minimum, smallest child of a house, leave them. Start with the middle child. Okay, then ask, are you same as the smaller one? If yes, then you have to increase it because you have no other option. You cannot decrease it. Okay, it is different altogether. So okay, go on to the next child. He is also same as the previous one. So for sure he should be increased. And from 2, I have to make it different than the previous 2. So from the previous 2, I have to make it different. So for sure, increase it such that it becomes a 3. So how much? Okay, I should make it increase by 1. Answer is 1. Cool. Let's apply the same standard. So we realize one thing by the above method, that we have to firstly sort it because we can only increase. The question for you in comment section, comment down below and tell me, if I gave you both the options, increase and decrease, what could have been the answer? But so far, and it's also a problem already available. So yeah, just comment down below what's the answer. But let's continue with the problem. It says that nums is 3, 2, 1, 2, 1, 7. I'll sort it. Then I will go. Okay, leave the first one as it is. Don't touch a small child. Take this child. Okay, he is same. So you have to increase it. He will become 2. Amount of increase done 1 so far. He will again, he is same as the previous one now. So increase it. He will become a 3. Again, 1 increase done. Answer is 2. He also has to be increased, but he has to become more than 3. For sure, he will become 4. Amount of increase done. Again, twice. Now, so far, I have got these much increase. Now 3, it is 4. For sure, he has to increase. He has to become a 5. Okay, increase done. Plus 2. That's right. Yeah. My number 7, it is already more than my 5. I'm good. So increase so far done is 6. Answer is 6. Cool. Last example, just for you for safety, we firstly sorted it, then leave it as it is. Start from here. It is more. Okay, go on. It is same or less. Why less, Aryan? It can only be same because you sorted the array. No, bro. You realized that we are changing the array values also. So make sure to make a copy. I'll not make a copy in the code, but yeah, make sure to make a copy. Then what I'll do? Okay, it's 3. Sorry, it's 2. Same as the previous one. I should increase it. Okay, increase it. Make a 3. Count again. Difference. You will add in the answer. Answer so far is 1. Okay, it is 2. It is 3. 2 is less than, which means my nums of I, it is less than nums of I minus 1. So whenever my nums of I, it is less than or equal to my nums of I minus 1, then I should basically increase it. Increase what? Increase nums of I. And how much? By simply taking a difference, again, you have to increase. Let's say take as extra. How much extra you have to increase your nums of I? Extra will be nums of I minus 1 minus nums of I. So nums of I minus 1 minus nums of I, that will give me a 1. But I have to increase it. I have to not make it equal, but I have to make it more than. So plus 1, make it more than. So this will make it equal to nums of I minus 1, but I have to make it more than. So plus 1. This is the extra. And simply add this extra in your answer, because that is what your move defines. So I will add the extra in my answer, and I will also add in nums of I will add that same extra, because you realize nums of I is becoming the new value. Cool. So in this case, from 2, I will get the extra as nums of I minus 1 is 3 minus 2 plus 1 will give me a 2. In the answer, which is existingly 1, I will add 2 more. It will become a 3. And then ultimately, in my nums of I should add the extra, which is 2. It will become a 4. And thus, I have got something as increasing and also for sure distinct. So the code is exactly same as what we saw. Firstly, we sorted, then we have an answer. Then I went on from I equal to 1. I left I equal to 0. Is the smallest child. Then if the nums of I is less than or equal to nums of I minus 1, although the array is sorted, so it should always be equal to, but you realize that you are changing the nums of I also. So although it's not recommended to change the array, make a copy of the array instead. If you want to change the array, it's always recommended. So make sure to incorporate. Again, right now I have not taken that array making stuff, but in the space complexity, I will incorporate that. Okay, what if I would have taken the space? Cool. Then I will increase in my answer by that extra amount, and same I will increase in my nums of I by that extra amount, and thus getting my answer done. So because of sorting and iterating on the array, it is O of n log n, it is O of n. So my time complexity will be O of n log n plus O of n. But my space, log n space for sorting, again for C++ and Java, for Python it's O of n. And because I was telling you that I will have to make a copy because I'm modifying the array, so I have taken the space also in consideration. Okay, now you know that if the interviewer asks you to optimize it, you know that you have done the sorting stuff. For sure, improvisation as in he wants something linear. Now linear, you know that you have watched Aryan all these videos. If not, please go and watch specifically this one video, which is the entire everything for counting sort or count sort. Then for practice problem, these two other videos. Every link will be in the description. So you realize that to optimize these sorting algorithms, we can think of applying counting sort. But for that, before even thinking, make sure to look at the constraints and see what nums of I maximum value is, because counting sort takes nums of I value or nums of I maximum value to find the array size. If this would have been only 9, I would have not been able to apply counting sort. Again, you can say I can apply, but not directly I can apply. Now, when I say I can apply, I was saying I can make buckets, but I can leave the empty buckets, which means I can still make buckets as 0, 1, 2, 4, 0, 1, 2, 6, 8. You saw I left 3, 4, 5. That is because I will take these numbers, I will hash them out as 0, 1, 2, 3, 4. This is that still are kind of these buckets or these counting sort algorithms can still be used, but still this is more or less a bit hashing will be involved to hash the new indexes with the existing ordered indexes. Okay, I'll not go into it, but yeah, it's just a hint for you to think of in the problems. Coming on back, we know that we can apply counting sort to just improvise it. How to apply it? Simply we know that we have watched this one video to know what counting sort is. Now we can simply make a array whose max, or you can simply build an array in which array of size 3 I will build, so that I can incorporate 2. 2 defines, index defines the element, and this number of the array, which is again, let's say a frequency array. So the value of the array is the frequency of that element, which is 2. So I know the 1 is coming 1 time and 2 is coming 3 times. So that's the array which I have built, frequency array. Now my task is simply, again, remember, maksad nahi bhulna. Your main aim was that if you have a 1, I say 1, 2, 2, 2, if you have this array built, which represent the frequency array, ultimately your goal was every number should come 1 time, which means no matter what, right now 0, 1, 2, right now the frequency of 2 is 3, frequency of 1 is 1, which is okay, but frequency of 2 should also be 1. and I should make sure that anyone who is occurring, again, he can be zero, but anyone who is occurring should occur once. That's my task. I will do the same thing. I'll do the exact same thing. How? Simply, I know I will go on from left. Why to go from left? From going on from left indicates I'm going on the sorted order of elements. 0, then 1, then 2, and so on and so forth. And we realize above why we need to go from the left, which means the sorted order. So as we go, we'll check, okay, frequency of 1 is 1, which means, okay, I'm good. I wanted, here the frequency of 0 was 0. I'm good. So I realized when the frequency of any element is less than equal to 1, I'm good. I don't need to do anything. There's no extra, there's nothing. I'm very happy. So I'll simply continue. Cool. Now, when I say continue, I'll go on to next index. Next index is 2. He will say my frequency is 3. You can simply say that you have 2. You have 2 extra, whose count are 2. So ultimately, I'm saying I have 3 2s in which 1 should remain here. Remaining 2 2s should go next, like should go more like next index. So you can imagine it as on a number line at the index 2, you have 3 balls. Technically, you have to shift these 2 balls to the next index. But you will say, Aryan, this is incorrect, right? Ideally, you should have shifted these balls, these 2 balls, not to the index 3, but 1 ball to index 3 and 1 ball to index 4. That's a good strategy. I will say you are correct. But I never know that do I have a ball at 3 or not. So ideally, you are saying that if I have 3 balls here, 1 ball at 3, I should check that who is having no ball in the right and all that stuff. No. With that logic, I will end up finding, okay, let's say if I have 2 balls, then I will end up going in the entire right just to find a location which has no ball and then put a ball there. Don't do that. Simply imagine, okay, I was at 2, my headache was extra 2 balls. Let's give that headache to the 3. I will give 2 balls to 3. Now, again, how much? Again, you just did 1 shift for how many balls? 2 balls. So ultimately, you have done 2 shifts so far. That is the inference. Earlier, you were doing the shifting of 1 ball. It is on, yeah, 1 ball you are doing. But here I am just saying I shifted 2 balls just once. So the number of moves are 2. Okay. Here again, on my 3, I had extra 2 balls. 1 will remain here, but I have extra. So for sure, again, extra 2 balls will be shifted right side. So 2 balls shifted to the 1 step, again adding a 2. Here I have 1 extra ball because 1 will still remain here, and then shift that 1 extra ball to the right side. So 1 ball will come here. And ultimately on the 5, I have 1 ball, I'm okay with it. I will go on left, like next is 0. I can keep on going until I find a ball. If not, I can just simply end. So you realize that with this strategy, I should only consider how many extra balls I have. I have to give those many extra balls to my next person. And how many extra balls I give, that will be the cost added for me. Now, this is the strategy which we found out, which will help us not to go and find the empty space later on. Cool. Now, let's come back to this example. Sorry, let's not erase it. Let's come back. So we realize in this case, I have all 3 balls at the index 2. Obviously, I will keep 1 ball. I will find the extra balls, which is 2 in this case. Again, how many extra? Simply, if my existingly frequency is 3, minus 1 will be the extra balls. So, extra balls will be frequency of I minus 1. It is the extra number of balls. I have 2 balls extra here. Simply shift these 2 balls to the next person. So these 2 balls will go from here and will come to my 3. And again, when I say come to my 3, existingly if 3 have some balls, keep it with 3. Add these 2 extra balls to 3. So I realize that frequency of I plus 1 should be increased by this extra number of balls, and as I'm doing 1 shift for these 2 balls, so the cost added will be 2. So in the answer I should add a 2 because there's a one shift done for two balls. Ultimately, it is saying one ball shifted by one ball shifted by one. So two balls shifted by one. And thus, I can now go on to my next index. As I go on to next index, again, he will keep one ball. Extra balls remaining will be one. Answer will be increased by 1. So far the answer was a 2. Answer is increased by 1. So do a add a plus 1. Right? And then next index, which is 4, should be added a value of 1. So he has one extra ball. And then ultimately I can simply say, okay bro, end it, because he has one ball. And I can go on to 5 also, but he has 0 balls, like no ball at all. So, okay, the array has ended. All the balls are finished. So, answer is 3. Now, you might go and implement it, but you might see one very beautiful case which you might end up missing. What is that? That you would have taken, because you know Aryan has taught count sort. In the count sort, Aryan has told that the array which we build for count sort has a maximum size of, okay, maximum element plus 1 is the, as you can see, maximum element is 2. So maximum size of the array will be 3. So that index 2 can come in picture. So you would have built this frequency array of size 3. But you realized ultimately you need the array of this much size. Of this much size you need. Ideally 4. How did this came in picture? This came in because you might end up, again, as I take the same example. Let's say you have 2, 2, 2, 2. So array will be of 0, 1, 2. Array will be of size 3 only because of 2. Maximum element is 2. Array index, last index should be 2. For last index to be 2, its size should be 3. I might end up placing 4 here. But if I place 4 here, he will distribute that 4. Okay, 1, 1, 1, 1. Because I have 4 elements. Sorry, 4 elements. So index 3, index 4, index 5. So technically you saw one very basic thing, that array size whatsoever you were building, which is maximum element plus 1, maximum element is 2 plus 1. This is what you were building earlier. Make sure to add n also. Technical, because you can have n. At max you can have n elements. So you will add 1, 1, 1, 1 n times at max. So make sure to add an n. That is your actual space of your frequency array which you will have to take. And this is something which makes this problem medium. That people will be confused why they are getting a runtime error, and to figure out what actual space they should take. Thus, we should take this as the space. So again, let's see the code. It's exactly same. It says that firstly, I took the maximum element, which is maximum element plus 1 plus my n. So this is my space, frequency array. I went on to all the elements, got my frequency. Then I went on the entire frequency array which I have. If the array size is less than equal to 1, which means it's a 0 or a 1, I'm good. I should continue. No extra, nothing added, no moves. If it is more, which means I will come down. If I will come down, I will find the extra first. How much extra? That much extra needs to be added both in answer and both in the next element. So I will add that extra in my next element, which is frequency of I plus 1, and also in my answer. And ultimately, I'll get my answer. Now, because of this, you know, the complexity will be O of n, because of you are actually going on to all the n elements, and also it will be O of k. Again, this will also take a O of n time, right? So no worries on that part, but roughly it will be O of n plus O of k. K as in, k defines your maximum element plus n plus 1, or you can say maximum element plus n, or n is already included in the complexity, so you can say as maximum element. So my complexity will be O of n plus k. Again, k you can just assume it as a maximum element, which is again bounded by 1e5. Space will also be same, O of n plus k, because of maximum element plus n plus 1 size array. And ultimately this is my answer. Again, it looks linear, but if my k would have been very less, it would have been much more efficient than n log n operation. If the k would have been very high, which means 1 is 7, then it would have been costlier than my n log n operation. Cool. Bye bye. Take care. I hope you guys got it. If yes, then do smash the like, baby, and see you in the next. Goodbye. Take care. Bye bye.